Hi everyone, in this video I'm going to discuss the product rule, which is appropriate when we are considering the derivative of two functions multiplied together. So the derivative of y with respect to x, for instance, where y is the product of two functions f of x times g of x. And the product rule tells us that in order to take the derivative here, we're going to first take the first derivative of f of x, so I'll notate that f prime of x. We multiply that by g of x, and then we add to that the first derivative of g of x, so g prime of x, and we multiply that by f of x. So for instance, let's consider y is equal to 12x squared times 4x squared. And here I can designate f of x is equal to 12x squared and g of x is equal to 4x squared. All right, we can apply our product rule. So we first take the derivative of f of x. Now to do that, I'm just going to use the power rule. I've already done videos on the power rule and other basic rules, so I'll link to that just up in the corner here if you need it. But we take the 2 out the front, that multiplies 12, so we get 24x to the power of 2 minus 1, which is just to the power of 1, so we just leave it as x. We multiply that by g of x, which is 4x squared. Then we add to that, we'll take the first derivative of g of x, so the 2 comes out and multiplies 4, so we've got 8 times x to the power of 2 minus 1, which is just to the power of 1, so we're just left with x, and we multiply that by f of x, which is 12x squared. All right, well, 24 times 4 is 96, and x times x squared is x to the power of 3. And then simplifying that second term, 8 times 12 is 96, and x times x squared is x to the power of 3 again. And this all ends up 192 times x to the power of 3. Now we can actually very easily confirm that this is the right answer here by approaching our problem a different way. So we've started with y is equal to 12x squared times 4x squared. Let's just do that multiplication. So 12 times 4 is 48, and x squared times x squared is x to the power of 4. And here, if we just apply the power rule to this function, y is equal to 48 times x to the power of 4, well then we get 4 times 48 times x to the power of 4 minus 3, which is 192 times x to the power of 3. So here we've confirmed our results by approaching the problem in two different ways. All right, let's do another example. Let's say we had y is equal to 4x multiplied by 3x plus 3. So here I'm going to designate f of x is equal to 4x and g of x is equal to 3x plus 3. Applying the product rule, we find, well, the derivative of y with respect to x, we're going to take the first derivative of 4x, which is just equal to 4. We multiply that by g of x, which is 3x plus 3. And we add to that the first derivative of g of x, which is, well, the first derivative of 3x is 3, and the constant 3 will just drop out. So that derivative is just equal to 3, multiplied by f of x, which is 4x. So opening that bracket, I get 4 times 3x is 12x, plus 4 times 3 is 12, plus 3 times 4x is 12x. And so this reduces to 24x plus 12. And you can confirm that as well if you want to by opening up the brackets in y and seeing that we can get to the same conclusion with our power rule if you want. In this video, however, just do one more example from economics that can actually trick people up. So total revenue is equal to price times quantity, and marginal revenue is equal to the derivative of total revenue with respect to quantity. So very often we do need marginal revenue, so we need to take the derivative of price times quantity, except the price here is dependent on quantity. So price is actually a function of quantity. And we can see this just by looking at our demand curve. You can see that the price will depend on how much quantity is produced. If we only produce a small amount, we can actually set the price quite high. But if we start producing more, we have to lower that price in order to sell that extra stock. So what price we can place on a good does depend on how much is being produced. So total revenue then is equal to price, which is a function of quantity, times quantity. And here we actually have two functions of quantity multiplied together. Price is a function of quantity, and quantity is a function of itself in a trivial sense, perhaps, but the value of Q does depend on Q. So actually, in order to take the derivative here, we have to use the product rule. So applying the product rule, let's set P of Q to be f of x and Q as g of x. So we get, if we take the derivative of total revenue, well, we take the derivative of price with respect to quantity and we multiply that by the quantity plus the derivative of quantity with respect to itself multiplied by the price. Now, dQ here is actually equal to 1. Quantity is in a one-to-one relationship with itself. So we find the following expression for the derivative of total revenue. It's dP dQ times Q plus our price, or our price function, if you will. And that's marginal revenue. And we do use this expression for marginal revenue when we're deriving some measures of markup and if we want to explore the relationships between monopoly, power and elasticity. So you'll probably run into this condition at some point. All right, well, that's it for the product rule. I hope that this helped. As always, thank you so much for watching my content. If you would like written notes to help you on your journey, or even just to support this channel to help me make more videos, you can visit my store. The notes include lots of practice questions with solutions, which can really help solidify your understanding of the skills discussed in these videos. Also, if these videos have helped, please like and subscribe, comment below, share, all of that. It all helps. Any feedback also is super welcome. Thank you so much for watching my stuff, everyone. Have a great day.